Hello everyone, I welcome you all to JK Tech Solution YouTube channel. Today in this video I am going to walk you through the coaxial capacitor design using ANSYS Maxwell. So let's start our session. So before getting into the design and simulation of coaxial capacitor, we need to know the formula for coaxial capacitor. The formula for coaxial capacitor is C equal to Q by V. This is a general formula as we all know. So which is equal to 2 pi epsilon L divided by ln of B by A, where here epsilon equal to epsilon naught into epsilon R. As you can see here, the coaxial capacitor, it consists of two concentric cylinders of inner radius A and outer radius B. So here in this cylinder, the inner radius is given with a positive charge and the outer radius is given with negative charge. And the length of the cylinder is considered to be L. Okay, so this is what a consideration we have considered for designing a coaxial capacitor. The next, so we need to know the design parameters of coaxial capacitor. So the dielectric constant for epoxy is 4.4. So in this video I am taken dielectric constant as FR4 epoxy, and then the inner radius of the cylinder A is equal to 5 mm, and then the outer radius I have taken it as B, which is equal to 15 millimeter, and the length of the cylinder is 50 millimeter. So these are all the design parameters we have considered for designing a coaxial capacitor. So this is what a manual calculation. So as we all know, C equal to 2 pi epsilon naught epsilon R L is nothing but length divided by ln of B by A. So I have substituted these values, design parameter values, in this formula. So after substituting all these values, I have got the capacitance value as 11.1346 into 10 power minus 12 farad, which is equal to 11.1346 picofarad. So this is what a capacitance value we have got manually. So next step is to simulate. So for that we need to open ANSYS Electronic Desktop Student. So after opening ANSYS Electronic Desktop Student, you need to click on File, New. Here we are going to design in Maxwell 3D. So after clicking Maxwell 3D, it will take some time for loading. So here I can rename my project. So first you need to click on rename. So here I am renaming my project as Coaxial Capacitor. Coaxial Capacitor 1. So I have renamed my project Coaxial Capacitor. After renaming it, you need to click on Maxwell 3D, solution type. Instead of magnetostatic, you need to click on electrostatic. Then click OK. So after giving solution type, you need to assign variables. For that, click on Maxwell 3D, design properties, add. Here the first variable I am going to add is inner radius. For that I have given the variable as A. Unit type, you need to click on L, length. So after giving length, so units is millimeter, the value of inner radius. So as we discussed in our video, the inner radius A is equal to 5 millimeter. So here I am going to substitute the value of A is equal to 5 millimeter. So this is for the inner radius A equal to 5 millimeter length. Then give OK. The next you need to click on add. The variable name is B. Unit type is length L. Okay, you need to click on L. You will get a unit type as length. The next millimeter, unit should be millimeter. The value of B. So as we have seen here, the value of B outer radius is 15 millimeter. So I have given the value of B as 15 millimeter. Okay. So then click OK. The next we need to substitute the length of the cylinder. Click add. Just give L. Okay, I have given here L. Okay, as you can see here, I have given here L. So the unit type you need to give on length. Sorry, for none length. You need to click on L. You will get the length millimeter. The value of length we have seen here is 50 millimeter. Okay, I am giving 50 millimeter. length value should be 50 millimeter. Then give OK, apply OK. So next step is to design. So first you need to click on cylinder. Okay, you can see here cylinder. Here we need to draw two cylinders, that are inner cylinder and then outer cylinder. For that you need to just click on cylinder 1, edit cylinder 1, edit, copy, then just give Control V, paste. Okay, so those two cylinders are created here. So rename the cylinder 1 as outer cylinder, and the material that we need to assign here as FR4 epoxy, FR4 epoxy. Okay, then just give apply. Okay, outer cylinder. Similarly, for cylinder 2, rename it as inner cylinder, in your inner cylinder, and then the material we need to assign here is FR4 epoxy. Okay, then just give apply. Okay, so as we know, for inner radius we have considered a variable A. So for the inner radius I am giving the value as A, and the length of the cylinder is 50 mm. So here for inner radius, inner cylinder, the radius is A, and then the height I am going to give here as L. Okay, so inner radius is A and then height is L. Just give apply. Okay. Similarly, for outer radius, you need to give the radius as B and then the height as L. Then just give apply. Okay. So as you can see here, the two cylinders are created, inner cylinder and then outer cylinder. Both cylinders are created, and we have assigned the material as FR4 epoxy. Now what we need to do here is to subtract the outer cylinder and inner cylinder. Just click on outer cylinder, control, then inner cylinder. Once again, you can just click on outer cylinder, then inner cylinder. Here you need to have an option called subtract. So here give subtract. In the blank part, you need to have outer cylinder, and then in the tool part, you need to have inner cylinder. Just give OK. So we have subtracted both outer and then inner cylinder. Now you need to click on inner cylinder. So as you can see here in the selection mode, you need to click face. Okay, so first you need to click in the selection mode face. After clicking in the selection mode face, click the inner cylinder, assign excitation, voltage. Here am I assigning the voltage as 1 volt. Okay, 1 volt. Then similarly, you need to assign excitation for outer cylinder. For outer cylinder, click on, again you need to click on face, click the outer cylinder. As you can see here, you need to have some space. Okay, so in the outer cylinder, assign excitation, voltage 0. Okay, you need to assign the voltage as 0. Okay, so 0 volt. In trimetric view, as you can see here clearly. The next step is to assign parameters. For assigning, you need to click on, in the project manager, click on parameters, assign matrix, voltage 1 and then voltage 2. Click OK. Then our next step is to give analysis. So for that, click on analysis in the project manager, add solution setup, then OK. Then our next step is to validate our design. So in Maxwell 3D, click validation check. As you can see here, our all the parameters are verified, so we are getting green tick. The next step is to give analyze all. You can see here our analysis step has been started. our analysis have finished. Now we need to click on Maxwell 3D. Results, create electrostatic report, data table. Here you need to click on see capacitance, matrix 1, new report. As you can see here, we have got the capacitance value as 11.229152 picofarad. So this is what the value we have got through simulation. Now we can check our value with the manual calculation. So as you can see here, we have received a value as 11.1346 picofarad in our manual calculation, whereas in our simulation we have got 11.22. Nearly the both values are same. Hence, we have successfully designed a coaxial capacitor, and we have verified both simulated and then manual calculated values. Then thank you so much for patiently watching to our video. I hope to see you again on next video. Thank you. Have a nice day.